Well, very good morning. My name is Karun Kant, and this course is solid mechanics. There is no one, although perhaps most of you know it by one. There is because the course number 2 is not there in the curriculum. So why should it used to be there in olden days? So it is a solid mechanics. It is the first course on mechanics of solid. We have started, instead of calling mechanics of solid, we are calling it solid. Okay. So, and this course is known by different names in different and different authors name it. So some people call it strength of materials, mechanics of materials. So if you see these names, the same. In fact, if you go to library 624 section, 624 is the classification. You find at least about 100 books on mechanics of solids. Introduction to mechanics of solids, solid mechanics, mechanics of materials, and various authors. So, some titles will be having introduction, and this has a very old history. It is not from, it is from the days of Archimedes, Galileo, Newton. So it has more than 400 years. So whatever I am teaching is not something modern. Maybe over the years we know how to teach the same subject by different means. So perhaps teaching methods have improved, or some material we'll be able to give in a better way, but otherwise the basic substance, basic material has remained the same for last 400 years. So it is a very old subject, and it's very important for all engineers. And you have done one course in mechanics. What do you mean by mechanics, or what does it concern? Mechanics, you have done a rigid course on rigid body mechanics, or engineering mechanics that it is called. So that was a rigid body. Body was rigid, it was acted by forces, it was in a state of equilibrium, and then you have to find out what? Under the action of forces, what happens to the body? What happens to the rigid body? That means you have to find out what kind of reactions are generated. If there is a friction, what is the kind of friction force that is generated between the two. So, but then the whole body was rigid, and rigid body, so rigid, study of equilibrium. That means if body is there, forces are acting, you have to find out the reactions, how it is supported, all those things will be there as it was there before. But then the other thing that has happened is deformation. Now deformation of the body should be such that there are no, if the body originally is continuous, then after the forces are applied, there is no discontinuity produced. It should not get lifted from the support. There should not be some crack developed, Continuity must be maintained. So we say second is we have to study deformation. And there we say we have to study this continuity condition, continuous deformation. and then we will relate. This is the second step. So this is the extra thing. Then now we have got force and deformation, and in the third step we will be relating the forces to deformation in some manner. Relationship between, what is the relationship between force and the resulting deformation. So the third step will be force deformation relation. If you make use of these three steps, equilibrium, condition of continuity, and study of deformation, and third one is force deformation relation, that means forces must be related to deformation, then you can solve the problem. Means you can study, you can find out all the reactions, you can study the behavior of the body. Okay, you can study the behavior of the body, and this I will illustrate through example. So our study will be 3 steps, and these 3 steps are very important. I must tell you about today what will be our textbook. There are 2 textbooks for this course. One is E.P. Popo, Engineering Mechanics of Solids. So POPOV, this is how a book is written technically. There is a way a name of the book must be written. Normally we write, there are various ways, but this is one of the ways in which a book is written when you write a report. So Popo, first name, last name is the first, then comma, then space, then EP, no space here, then comma, again space, name of the book, Engineering Mechanics of Solids. Every word the first letter of every word must be in uppercase. It is not newspaper writing. Technical writing has its own rules. So the way a book is written in any printed material for technical reading, it has to be Engineering Mechanics of Solids. Again comma. After every comma there must be a space. This is, I don't know, the sign of space. When I was a student 45 years ago, this was there. When we used to write computer program, space. One space. Then the edition of the book. Again comma. Then the publisher. Who is the publisher? Because unless you know the publisher, you cannot locate the book. Second edition, then Prentice Hall of India. Then where is published? Where is the office of this publisher? It is in New Delhi. What is the matter? And then when it was published, this book, second edition. So for example, you have to go back, see the back of this page. And of course, there must have been reprinted. Second edition, it says, in India it has been published in 98 was in US, copyright 98, but then in India they have 2010 printed. And then full stop. So this is the way name of the book is. So this is your first textbook, And second textbook that we will be also following, both of us. There are two teachers for this course, so both of us will be following this. So this is another book. As such. Second edition, and this is by Tata McGraw-Hill. I think this also is 2010. Yes, fifth reprint. Okay. 20 reprints are not called as edition. 2010. So these will be your two textbooks. You are expected to have one of these two books. They are all available, easily available. So both are reprinted in our country. So this is first. Then I must tell you about what is our, yes, before I forget, because otherwise I will forget. So there will be, next thing that you will be asking is this timings. This is Monday 9:30, Tuesday 10:30, and then Thursday 11:30, and this we call slot number 2. So this is slot 2. But then there is also a tutorial. This is a 8 credit course, means 3 lectures and 1 tutorial. Sometimes the tutorial will be converted into lecture, because in the beginning, since there will be certain portion to be covered before we can start solving problems, so we will convert the tutorial into lecture. But there is a tutorial and there is a change. Only today morning it happened. Earlier it was on Monday, now they say 10A. So here it is Tuesday, 14 hours, and the slot is 10A. I think there was some clash, 14 to 2 to 3, 14 to 15 hours. It will be in the same year on Tuesday. So Tuesday you have 2 left. So this will be your then method of evaluation, that is most important. How do we evaluate, because there will be about 130 students for the entire. By the way, this has been after a lot. I used to teach the entire class, 120, 25. Then we found that it was difficult. They were not receiving, the students were not getting benefit of our lecture. I mean, there were two ways. One is it becomes very impersonal, and since this is a basic course, we thought that we must split it up into two, and that is, so it is for your own benefit that it has been made into a smaller group. So now this will be about 58 or 60 students, 58, I mean, as you say. So this is, it has been done from this year, and this will be throughout, I think. Now from second year onwards, for all courses you will be split into, mostly split into two. The idea is that perhaps you will receive the material better, otherwise it becomes a crowd. We don't want to. So this is, but then evaluation. Normally we have a mid-semester, mid-sem test or exam, and you have a end-sem. Since the number is large, it will be purely based upon your performance in the test. So this is, we will keep this end semester 50%. We will keep this mid semester, although this will be 2 hours, but 30%. And we will introduce here a quiz. Quiz 1, and that will be 10% here, and there will be a quiz 2. Please do not talk. Yes, yes, please. So this is 10%. So that makes it 100. So this will be the dates of this mid semester, end semester will be announced centrally. Those are fixed. Quiz we will announce, when we will take the quiz. Normally it will be in between. So we will announce when will be the quiz exam, test, and there will be a common paper for both the divisions. So we will try to follow similar things, in both the classrooms. So this is as far as this goes. Your evaluation goes. Anything else that you would like to ask? Anything that bothers you at this moment? I'm going to, something that I might have forgotten. Okay, so after rigid body, so now we go to, so as I told you, there are 3 steps involved in mechanics of solids, and I will illustrate these 3 points through a simple example. And let me take an example. Yes, both are. So let's, about which we are familiar. So it is a problem that is not very. We have the roof, and from the roof we have 3 springs which are hanging, and then there is a rigid rod, that is attached to these 3. So originally this rod, of course the 3 springs, yes, 3 springs must have their own spring constants. So let us say Ka, Kb, Kc, let it be general. See, this is the ceiling. and this is a rigid rod. And the distances are, so this is, these distances are, they are equidistant. So this is A, this is also A, this is also A at a distance A. So these 3 points are A, B, C, and it so happens that when there is no load, this is horizontal. Okay, somehow we have, will it be horizontal or not? Tell me. It is possible. So 3 springs, and this is like this, and then I apply a load here at a distance, some distance from the center. Center point is there, so I am just calling it as a fraction of A, maybe A by 10, A by 5, A by 2, lambda can be anything, lambda is one, what, a fraction. And we have to find out the position of this rod after application of this load. So now here I have introduced, this is not only a rigid body, I have also introduced flexible members which deform this. So total system is a deformable system, although this is rigid, connected to deformable springs. And then after deformation, after the loads are applied, this will take, because it is rigid, so it will remain straight. First of all, it will remain straight, I don't know. So let us say that this position will be, it will be coming some position like this, and say that this deflects the center point, the center of B and center of this rod here. These 3 deflections, it will be, this will be 3. So call it as delta A. This deflects by delta A. A point has deflection of delta A, B has a deflection of delta B, C has a deflection of delta C. These are unknowns, and of course P is acting here. See, there is, when it is horizontal there is no P. Is it clear? When it is horizontal there is no P applied. Only after application of P it takes a deflected. Now our job is to study the behavior of this system. Study means I would like to know what are the displacements produced, what are the forces produced. Okay. So how to go about it? Oh, now I don't know, I think we have to take attendance also. So think about it. Okay, so then I think let us, as far as this is concerned, we will stop here today.